The National Electrical Code, also known as NEC, requires that all electrical outlets within 6 feet of a bathroom sink be protected by ground fault circuit interrupter, which is commonly referred to as a GFCI. Each bathroom must have a dedicated circuit for ground fault circuit interrupters protecting outlets within that bathroom. The circuit must be a 20 amp circuit using number 12 American wire gauge, also known as a WG wire. It is not permissible to wire the ground fault circuit interrupters from multiple bathrooms to the same 20 amp circuit. Ground fault circuit interrupters are available in 15 amp and 20 amp ratings. It is recommended to use 20 amp ground fault circuit interrupters for bathroom circuits. To properly install the wiring, firstly, install a 20 amp circuit breaker or fuse in the electrical panel for each bathroom ground fault circuit interrupter circuit. Secondly, run number 12 American wire gauge wire from the panel to a junction box in each bathroom. Thirdly, install a 20 amp ground fault circuit interrupter in each bathroom junction box. Fourthly, connect the ground fault circuit interrupter to the incoming power and to the outlets that it will protect. To reiterate, each bathroom must have a dedicated 20 amp circuit for ground fault circuit interrupters protecting outlets within that bathroom. It is not permissible to wire ground fault circuit interrupters from multiple bathrooms to the same circuit. It is best practice to use 20 amp ground fault circuit interrupters for bathroom circuits. Understanding the National Electrical Code requirements for ground fault circuit interrupters in bathrooms is crucial for ensuring electrical safety and code compliance. The National Electrical Code clearly stipulates that each bathroom must have its own dedicated 20 amp circuit for the ground fault circuit interrupters protecting the outlets within that bathroom. This means you cannot connect the ground fault circuit interrupters from multiple bathrooms to a single 20 amp circuit. This regulation is in place to prevent overloading the circuit and to ensure that if a ground fault occurs in one bathroom, it doesn't affect the electrical safety of other bathrooms. Using number 12 American wire gauge wire is essential for 20 amp circuits as it is designed to safely handle the current load without overheating. Although ground fault circuit interrupters are available in both 15 amp and 20 amp ratings, it is highly recommended to use 20 amp ground fault circuit interrupters for bathroom circuits. This ensures that the ground fault circuit interrupter can handle the potential load from multiple devices plugged into the outlets within the bathroom. When installing the wiring, begin by installing a 20 amp circuit breaker or fuse in the electrical panel for each bathroom ground fault circuit interrupter circuit. This provides overcurrent protection for the circuit, preventing damage to the wiring and appliances in case of a fault. Next, run number 12 American wire gauge wire from the electrical panel to a junction box in each bathroom. The junction box serves as a central point for connecting the wiring to the ground fault circuit interrupter and the outlets. Install a 20 amp ground fault circuit interrupter in each bathroom junction box. The ground fault circuit interrupter should be installed according to the manufacturer's instructions, ensuring that it is properly grounded and connected to the power source. Finally, connect the ground fault circuit interrupter to the incoming power and to the outlets that it will protect. Ensure that all connections are tight and secure to prevent loose connections and potential electrical hazards. By following these steps and adhering to the National Electrical Code requirements, you can ensure that your bathroom electrical system is safe, reliable, and code compliant. Remember that working with electricity can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation. In summary, when wiring bathrooms with ground fault circuit interrupters, remember these key points. Firstly, each bathroom requires a dedicated 20 amp circuit. Secondly, do not connect ground fault circuit interrupters from multiple bathrooms to the same circuit. Thirdly, use number 12 American wire gauge wire for the circuit. Fourthly, install a 20 amp circuit breaker or fuse in the electrical panel. Fifthly, run the wire to a junction box in each bathroom. Sixthly, install a 20 amp ground fault circuit interrupter in each junction box. Seventhly, connect the ground fault circuit interrupter to the power and outlets. By following these guidelines, you can ensure a safe and code-compliant bathroom electrical system. The importance of dedicated circuits in bathrooms cannot be overstated. Firstly, dedicated circuits prevent overloading. Bathrooms often have multiple high-power appliances such as hairdryers, curling irons, and electric heaters. If these appliances are all used simultaneously on a shared circuit, the circuit can easily become overloaded, leading to trip breakers and potential fire hazards. Secondly, dedicated circuits reduce the risk of nuisance tripping. Ground fault circuit interrupters are designed to trip when they detect a ground fault, which is an unintentional electrical path to ground. Shared circuits can be more susceptible to nuisance tripping due to the cumulative effect of minor leakage currents from multiple devices. Thirdly, dedicated circuits improve safety. In the event of a ground fault, a dedicated circuit will isolate the fault to the bathroom where it occurred, preventing it from affecting other areas of the house. This can help to minimize the risk of electric shock and other electrical hazards. Fourthly, dedicated circuits comply with the National Electrical Code. The National Electrical Code mandates dedicated circuits for bathrooms to ensure electrical safety and prevent overloading. Failure to comply with these requirements can result in code violations and potential liability. In addition to dedicated circuits, the proper wiring and installation of ground fault circuit interrupters are also crucial for bathroom safety. Ground fault circuit interrupters should be installed in all bathroom outlets that are within 6 feet of a sink or water source. These devices are designed to detect ground faults and quickly interrupt the circuit, preventing electric shock. When installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions carefully. Ensure that the ground fault circuit interrupter is properly grounded and connected to the power source. Test the ground fault circuit interrupter after installation to verify that it is functioning correctly. It is also important to use the correct type of wiring for bathroom circuits. Number 12 American wire gauge wire is recommended for 20 amp circuits as it is designed to handle the current load safely. Avoid using undersized wiring, as this can lead to overheating and potential fire hazards. In summary, wiring bathrooms with ground fault circuit interrupters requires careful attention to detail and adherence to the National Electrical Code requirements. Dedicated circuits, proper wiring, and correctly installed ground fault circuit interrupters are essential for ensuring electrical safety and preventing potential hazards. If you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician. Choosing the right ground fault circuit interrupter is also critical. While both 15 amp and 20 amp ground fault circuit interrupters are available, 20 amp versions are generally recommended for bathroom circuits due to their ability to handle higher loads. Consider the potential load of all devices that might be used simultaneously in the bathroom, such as hairdryers, curling irons, and electric heaters. A 20 amp ground fault circuit interrupter will provide more headroom and reduce the risk of tripping. When installing the ground fault circuit interrupter, ensure that it is properly connected to the circuit wiring. Follow the manufacturer's instructions carefully to avoid wiring errors. Pay attention to the line and load terminals, as connecting them incorrectly can prevent the ground fault circuit interrupter from functioning properly. After installation, test the ground fault circuit interrupter to verify that it is working correctly. Use a ground fault circuit interrupter tester to simulate a ground fault and ensure that the ground fault circuit interrupter trips as expected. This is an important step to ensure that the ground fault circuit interrupter will protect against electric shock in the event of a real ground fault. Regular testing of ground fault circuit interrupters is also recommended. The National Electrical Code recommends testing ground fault circuit interrupters at least once a month to ensure that they are functioning properly. This can be done using the test button on the ground fault circuit interrupter. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. In addition to ground fault circuit interrupters, arc fault circuit interrupters are another important safety device for electrical circuits. Arc fault circuit interrupters are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. Arc faults can occur due to damaged wiring, loose connections, or other electrical problems. Arc fault circuit interrupters are required by the National Electrical Code in many areas of the home, including bedrooms, living rooms, and dining rooms. While arc fault circuit interrupters are not typically required in bathrooms, they can provide an additional layer of safety. If you are concerned about the risk of arc faults in your bathroom, you may want to consider installing arc fault circuit interrupters on the bathroom circuits. When selecting wiring for bathroom circuits, it is important to choose the right size and type of wire. Number 12 American wire gauge wire is recommended for 20 amp circuits, as it is designed to handle the current load safely. Use non-metallic sheath cable, also known as NM cable, for most bathroom wiring applications. NM cable is easy to work with and provides good protection against physical damage. Ensure that the wiring is properly secured and supported to prevent damage. Use cable staples to secure the wiring to studs and joists. Avoid running wiring through areas where it could be damaged by nails or screws. When making connections, use wire connectors that are appropriate for the size and type of wire being used. Ensure that the connections are tight and secure to prevent loose connections and potential electrical hazards. In addition to the National Electrical Code, there may be local electrical codes that apply to bathroom wiring. Check with your local building department to determine if there are any additional requirements that you need to follow. Obtaining a permit may also be required for electrical work in your bathroom. Contact your local building department to determine if a permit is necessary. In summary, wiring bathrooms with ground fault circuit interrupters is a critical aspect of electrical safety. Dedicated circuits, proper wiring, correctly installed ground fault circuit interrupters, and adherence to the National Electrical Code are essential for preventing electric shock and other electrical hazards. By following these guidelines, you can ensure that your bathroom electrical system is safe, reliable, and code compliant. Remember that working with electricity can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation. Moreover, remember to always turn off the power at the breaker before working on any electrical circuits to prevent the risk of electric shock. Double check that the power is off by using a non-contact voltage tester before touching any wires. This simple step can significantly reduce the risk of electrical injury. When working with wires, use insulated tools to protect yourself from electric shock. Wear safety glasses to protect your eyes from flying debris. Work in a well-lit area to ensure that you can see what you are doing. Keep your work area clean and organized to prevent accident. If you are not comfortable working with electricity, it is always best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and correctly. They can also ensure that your electrical system is code compliant and meets all safety requirements. Remember that electrical work is not a do-it-yourself project for everyone. If you are not confident in your abilities, it is always best to leave it to the professionals. By following these safety precautions, you can minimize the risk of electrical injury and ensure that your bathroom electrical system is safe and reliable. Furthermore, consider the long-term maintenance of your bathroom electrical system. Regularly inspect the wiring, outlets, and ground fault circuit interrupters for signs of damage or wear. Replace any damaged or worn components immediately. Keep the outlets and ground fault circuit interrupters clean and free of debris. Avoid overloading the circuits by plugging too many devices into a single outlet. If you notice any problems with your bathroom electrical system, such as flickering lights, buzzing sounds, or trip breakers, contact a qualified electrician immediately. Do not attempt to repair electrical problems yourself unless you are a qualified electrician. Proper maintenance can help to extend the life of your bathroom electrical system and prevent potential hazards. Also, consider energy efficiency when selecting electrical components for your bathroom. Choose energy-efficient lighting fixtures and appliances to reduce your energy consumption and save money on your electricity bill. Look for products that are Energy Star certified. These products meet strict energy efficiency guidelines set by the Environmental Protection Agency. Consider installing a dimmer switch for your bathroom lighting. Dimmer switches allow you to adjust the brightness of the lights, which can save energy and create a more relaxing atmosphere. In addition to energy efficiency, consider the aesthetics of your bathroom electrical system. Choose outlets and switches that match the style of your bathroom. Consider using decorative cover plates to add a touch of elegance. Pay attention to the placement of outlets and switches. Place them in convenient locations where they will be easily accessible. In conclusion, wiring bathrooms with ground fault circuit interrupters is a complex and important task that requires careful planning, attention to detail, and adherence to the National Electrical Code. Dedicated circuits, proper wiring, correctly installed ground fault circuit interrupters, and adherence to safety precautions are essential for ensuring electrical safety and preventing potential hazards. By following these guidelines and consulting with a qualified electrician when necessary, you can create a bathroom electrical system that is safe, reliable, energy efficient, and aesthetically pleasing.